So that brings us to the FAWS. So what is our FAWS? The flow-through automatic watering system consists of the following components: the main grow bed, medium, main pumping system, reservoir, automatic timer systems, the flow-through and sprinkler systems, the vertical gardening systems, sustainable energy sources, and electrical systems. So let's go through that. So our main grow bed, well, here we can see a picture of the first main grow bed that we built at Raktamachat. It's changed over its lifetime to have different uses as we were learning about or researching about permaculture and permaponics, if you will. So the main grow bed is a welded steel rectangular frame of any length with approximately a double width person. So the concept here, don't worry too much about what your grow bed looks like. Let's talk about the principles of what a grow bed may be. Here it's elevated, so let's call it a raised bed. And what we want to think about is what's called double reach gardening, or a double reach bed. I reach from one side, so my bed should not be any wider than my width. If I'm standing here, I can reach this far, and I work ergonomically. If it's further, I get stuck. And if it's lower, my angle changes, so my bed width changes. So if I elevate the bed, I can get wider bed, which is called least path design. So imagine if there were many of these beds elevated, then I would be able to have more bed to path in a certain area. So I would grow more within a particular area because the bed's elevated. That's also good for ergonomics. Imagine the picture that we saw where a person in a wheelchair would be able to reach over and work in the bed. So these are different types of reasons, and we can see their guy reaching over, working in that bed. This is actually a replica of a chinampa, because inside of this bed, we'll see that there's a pond, if you will, to represent that the standing water wicks into the beds. So inside of that bed, though, we have to do different growing mediums. And dependent on what we're growing, we can use bags, big bed, full-size beds, bags, containers. And what that does is allow us to change the height in relationship to the water level. And the different height of soil allows a different consistency of moisture. So certain plants like what we might describe as wetter roots than other plants. So some plants like a different water condition. So we can grow two different plants that like two different watering conditions side by only adjusting the height of the soil in relationship to the constant water level. So that's another, maybe say, advantage of permaponics with utilizing bags. So these are where we're loading up those bags. The grow bed has to have some type of medium put into the bed and or bags in the bed. So the soil can be composed of compost, which we make here, worm castings, biochar, dirt, if you want to have a little bit more structure from dirt, potting soil, or any combination of these materials. So we have our own, what we call our designer mix that we use, very high in biochar. So for our permaponics, we'll go as high as 50% biochar in the mix for structure, and then top up compost as we're growing over different growing cycles, and also topping up worm castings, and we have other flow through, we'll see nutrient sources. So here we can see that we had worm bins under our grow bed. So the water, when we water, remember the recirculated nature, that one that showed the grow bed and it captured and they recirculate it. Well, we took that idea and we took the water into the worms, and then when it comes out the worm, there's a reservoir that takes the worm tea and pumps it back into the pond, which dilutes it back into the plants. So that's our closed loop nature. So here we have making biochar to compost to worms. The bag's also key. It gives us a wicking availability into the root zone, and it makes the nutrient available to the plants at all times. And our main pumping system, we have a submersible pump. So we have a just standard 1-inch submersible pump that's hanging from that sawlog that we can see there over the pond. And with a simple float valve, when there's not enough water for the system through evaporation from the pond area or transpiration from the plants, then the float valve changes, says I need water, tells the pump turn on. It's just basically an automatic light switch with a float. We'll see that in a second. And then the pump brings in enough water. When it's full, says okay, that's it. So in an automated fashion, it always has the correct amount of water. So that brings us to our reservoir pumping systems. So in this instance, this system goes to quite a bit of systems around Raktamachat. But there's several other pumps inside of reservoirs and the system, and they serve various functions. We can sprinkle the plants from the top. It was important that I wanted to be able to start seedlings in my system. So if I started my seedlings, I could turn on a sprinkler. But as the plants got developed, their root zone would come to the wick, and then we wouldn't need to top water the plants. And that could be advantageous for, say, tomatoes, which don't like to be watered on their lettuce, on their leaf structure, for instance. So recirculation of worm tea, as we saw with the worm bends under, we can recirculate worm tea. We can add various biofertilizers that we produce on site, EMs, and watering the nursery. So any excess water, we can take water from this system that's been nutrient laden and we bring it to our nursery. So when the nursery pump turns on, it takes the nutrient laden water that's created in the Permaponic system to water our seedlings, which are then brought back to plant into the Permaponic system. So you can say that this water from the nursery and Permaponic system is the same. And because we say split or utilize the same nutrient system for two different purposes, one being a grow bed, one being a nursery, seedlings. And then we have sprinklers built in from the seedlings, and those have nutrient-laden water, again, from the Permaponic system. So when we were learning to do this, one of our problems was buying the particular sprinkler that was right. Because our system has soil and all these things we're putting in it, it's going to be not, say, dirty water, but it's soil water, right? It's water coming through soil. So it has particulate matter. It has leachate in it. We want to recirculate that leachate. So we had to get sprinklers that had big enough orifices so that it wouldn't get little particles stuck in it. So it took us about 3 or 4 sprinklers to find the right one that worked. So with our particular fish tank pump we were using, small, so we didn't have a lot of pressure. So we had to find the right sprinkler and had the right orifice, and then we had no problem with clogging. So we didn't have issues with like our sprinklers getting clogged up. But that took a little bit of experimentation. So recirculation of our worm tea, very important. So as we have our worm bends, the worm bends are watered from the reservoir. So when the pump comes on, a certain amount of water goes to the worm bends. It drains through the worm bends into a reservoir and is pumped back with a fish tank pump and a float valve again into the reservoir, diluted to the plants on a continuating fashion. So again, our worm bends, I don't need to water. So we don't have to water our worms. We don't have to take out. Everything's automated. And functionally, all you have to do is plant your seedlings or seeds. And at the end, once you've grown, you can re-top up with compost. So we're just topping up with compost, just like we do in a normal garden, everything else being more automated. And we can add in bioteas automatically. So here we see what's called a venturi. A venturi uses the pressure of a pump. So if I have a pump and it pumps, there's a pressure. So, but what happens is, utilizing Bernoulli's principle, we put in a restriction. So when this water is pumped through the restriction, it has to increase its speed. When it increases its speed at the restriction, you drill a hole, and that creates a vacuum. And a tube into a reservoir with the pump creates the vacuum to suck a certain amount of, say, in this solution. And we use a valve. And we can control the amount of solution entering the stream and then calculate the dilution rate. So at this point, if I have this setting, I can add in 1 liter per 100 liters, if that's the dilution I want, 10 to 1. So I can do that. So this very simple, $5 Venturi from a gardening supply store. Here we can see where we have, we utilize ICBs, international bulk carriers. They're quite inexpensive. With a simple float valve, we're able to keep the pressure, or so not pressure, but height of water. So this water, this ICB is lower than the main grow bed. So if the main grow bed, right, has a certain level, there's a drain, and if this one, the float valve goes down, it takes water from the main grow bed. And if it takes water from the main grow bed, then the grow bed says I need more water and fills up. And then this is what I might call balancing your system. So with gravity, right, we only have to pump once. And gravity flows water to all of the subsystems at a lower level. You could almost be infinite if you went down a large hill. So as long as I put water in the top one, it's full, then full. And this is exactly the replica that we see utilized in terraces. So in terraces in Southeast area, you're doing water, they functionally fill up the top terrace, and the water drains to all the preceding terraces and flows through. And that's what's interesting. So the nutrient or leachate from the top terrace actually goes to the bottom, and the rice does better at the bottom because it has more nutrient through leaching. So that's what we want to look at, these principles which are ancient, from whether it's the Mayans all the way in South America doing it that way, or the Babylonians in North Africa, or it's Southeast Asians around the Philippines to Thailand to Bali, Indonesia, utilizing terraces, it's the same concept of how water works, or water working. And we have sprinkler seedlings, so there's additional worm bins in the nursery. They top up the nutrient value for our seedlings, and any excess worm tea gets pumped back into the 1,000 liter ICB for the next cycle. And we use automatic timers. These are very simple timer that you can purchase. It's about $5 here in Thailand. So there's only one main timer within that total Permaponics system that we showed you. That's one of our medium-sized system. In our commercial system, we have more timers because it does more things. But all other timer circuits cycles are based on the main timer. So even if we utilize more timers, they're still always set to the main timer. So the main timer gives us 24 hours a day. What time is it? And then everything else is just a subset of that if you have an expanded system. So it's quite modular. I can build one and add on to it, and add on to it, and add on to it, and add on to it as many times as you like, as long as you have gravity or another pump. No problem. So this is a float valve that we'll show you. Later there'll be more videos and all this good stuff that individually, but electric float valve controllers, right? This is interesting. Again, $5. In our Permaponics system that we currently have that you're seeing, we have 2 of them, and they control the reservoir in the worm tea and our main reservoir. So if there's not water, turn on, bring me water, or if our worm bins fill up, it pumps water back to the reservoir. So we only utilize 2 of these in our system. And we can see that they can do different things, meaning that depending on how you wire this one, an A1 or an A2, it can either pump or drain. So what are you trying to do with it? And description. So third does that. Automatic timer systems. So we have a manual float valve in the falls, which is controls. So there's currently one in our system at this time. It's inside the 1,000 liter tank, which is used to water our nursery, and it's connected to the discharge of our main growing beds. And it shuts off the flow when the tank is full. So you might call this a static, non-electrical float valve. Very simple. It's what's in the back of most people's toilets. So when the water's full, it doesn't take any more water. When you flush the toilet, the float goes down, more water fills the tank, it turns off. Very simple, very cheap. We might describe some of these parts, or what we like to use, as bulletproof. When you install it, it doesn't break. It can be there for 10, 20 years. It's not going to break. So these are things that we want to have that robust nature to alleviate maintenance. So that's an important part, very low maintenance. Also in our falls, we have our flow through and our sprinkler system. So the flow through and sprinkler systems are designed to evenly distribute the water and the nutrients to the plants 24 hours a day. This constant water and nutrient supplies allows for our maximum growing rate of the plant throughout its life cycle. And we can integrate vertical gardening systems into our system. So as we saw with our worms, where the water flows through the worm bed into a reservoir and is pumped back up. Equally, we can drip water through vertical watering systems to a reservoir, and with the technology that you can learn with the float valves and a fish tank pump, you're able to pump the water back up to complete the cycle, and with a timer, you can do that multiple times a day. So in this instance, we can see how growing or vertical growing aspects can be added to your grow beds. So the Permaponic grow beds allows for 2 types of vertical growing systems. One for drip irrigating plants down or along the sides of the main grow bed, and the second for growing runner type plants like cucumbers and or gourds up into the canopy. So we have a structure that over the growing bed. So if you have a high sun area like we do here in our dry season, it's very sunny or too sunny to grow leafy vegetables, for instance, we can utilize a canopy to be artificial canopy to be grown out of gourds, pumpkins, whatever type of thing like that, cucumbers, to create what a dapple sunlight. So we can control the sunlight through our canopy, utilizing, again, a type of vertical gardening system. And we need to utilize sustainable energy as a principle of Permaponics. We would typically want to utilize sustainable energy. So at Raktamachat, our Permaponics system is powered by a sustainable energy source. Here you can see a dam with a hydroelectric dam is where we get our power from. We also can power our system with solar. We utilize 60 watt basically pumps. So one 100 watt solar panel can easily run our pump. And we only run in our commercial system for 1 hour a day. So it's quite easy to have a single solar panel with a small inverter to run a fish tank pump and basically take care of a whole hydroponic system, or Permaponics in this instance. And so no rivers dam to operate so some people may say that's a river. No, it's a reservoir. They dammed a mountain range, so that water is collected during the monsoon. So there's no, say, fish or species that are not able to move because of the dam. And electrical wiring, or the wiring diagram. So at the beginning, our wiring diagram, this is the original wiring diagram, pictorial. And you'll see later in the Permaponics course, if you will, a more stylized or simplified Permaponics diagram. So the Permaponics system has some unique and intricate electrical features. What does that mean? Well, we tried to simplify it. So currently there's only 2 wires. So we have 2 wires, there's input and output that flow through it. And we can walk you through that process of how we can basically make automatic timers, automatic switches, and float valves. So only 2 wires, input to output, this to that, and you'll be able to utilize your system. And it's, in that instance, reasonably, we believe, simple.